Good morning, students. Welcome to physics class. Now you imagine that we are entering into a dark room. Can you see any objects there? No, we cannot see any objects even if our eyes are open. Why can't we see the objects? Why? Because there is no light. So we cannot see any object if there is no light, even if our eyes are open. We perceive 80% of the world around us through the sense of sight. So it is understood that without light we cannot see any objects around us. How do we receive this light? So we receive the light by the natural resource, that is the sun. So during the daytime we could see the objects with the use of the sunlight. And at night we are using electrical bulbs. So the objects that gives light are called as luminous object, and the other objects are called as non-luminous objects. So the non-luminous objects will reflect the light, and the reflection will enter into our eyes, and so that we could see the object. So now you could understand the topic of our lesson. Yes, it is light. So we are moving to the next lesson, that is light. So we know different forms of energy. Light is also a form of energy which travels in the form of electromagnetic waves. So light travels in the form of electromagnetic waves. And the branch of physics that deals with light is called as optics. So the branch of physics that deals with the light is called as optics. And we are using different equipments in our laboratories that works with the principle of light. That is microscope, the telescope, etc. So light waves travel in the form of electromagnetic waves. Okay. So when light falls on an object, it gets reflected. So this is the important property of light, that is reflection. So when light falls on a polished surface, it gets reflected. Now let us learn reflection of light. Light falling on any polished surface gets reflected. So this reflected light follows some laws. Now consider a polished surface or a mirror M dash. Consider a mirror M dash. So let AO be the light ray gets incident on the polished surface. So AO at O. Let AO be the incident. Light gets incident at O. And this light ray is called as incident ray. The light ray AO is called as incident ray. The light ray AO gets incident at the polished surface at O, and it gets reflected. And this ray, the reflected ray, is called as OB. So this ray is the reflected ray. So this is the incident ray, AO is the incident ray and OB is the reflected ray. So the line drawn at O is called as the normal. The line drawn at the point O is called as the normal, which forms an angle I with the incident ray and forms an angle R with the reflected ray. This now draw a normal at the point O, which forms an angle I at the incident ray and angle R at the reflected ray. So this angle I is called the incident angle, and R is the reflected angle. So this is a light ray AO, incident at a point O, which gets reflected. So AO is the incident ray, OB is the reflected ray. So at the point O, we are drawing a line that is called as the normal, which forms an angle I with the incident ray and forms an angle R with the reflected ray, and I is called as the incident angle and R is called as the reflected angle. Based on this, we have the laws of reflection. There are two laws of reflection. The first law is the incident ray, the reflected ray, and the normal lie in the same plane. So this is the first law. The incident ray, the reflected ray and the normal lie in the same plane. This is the first law of reflection. And the second law is the angle of incidence should be equal to angle of reflection. That is, angle I is equal to angle R. These are the two laws of reflection. The incident ray, the reflected ray and the normal all lie in the same plane. And the second law is the angle of incident should be equal to the angle of reflection. That is, angle I is equal to angle R. Next, let us learn lateral inversion. You might have heard about inversion, but what is lateral inversion? Lateral inversion is derived from the Latin word latus, which means side. So it is a sidewise inversion. It is the apparent inversion, that is from left to right and right to left in a plane mirror. But what is actually happening in a plane mirror? Does it reversing up and down, or it is reversing left and right? No, it is not reversing left and right. Also, it is not reversing up and down. But what is happening actually is an optical illusion which appears to be reversing left and right to left. But it is not so. It is only reversing the inside out. But for us, it appears to be reversing left and right and left. So this is called as lateral inversion. What appears to be, it appears, not exactly the thing, it appears to be inverting right to left and left to right. So this is called as the lateral inversion. Let us learn what is the real image. So here, light rays coming from any object. So this light rays gets reflected. So here the light rays, it is getting incident here and it is reflected. So like this, and here it is coming, getting incident like this, and the image is formed at this position. So this is called as a real image. So when do we call this as a real image? So if a light ray coming from an object, after reflection, if it meets at a point, see all the rays are meeting at a particular point. So in this case, the image formed is a real image, and the image formed will be an inverted image. So this is a real image. So what is a real image? The light rays coming from a distant object, after reflection gets or meet at a particular point. So this is called as a real image, and the real image will be an inverted image. So this real inverted image can be caught on a screen. The real image can be caught on a screen. So what is a real image? The rays after reflection, if they meet at a point, the image formed is called as a real inverted image, which can be caught on a screen. Next, let us learn virtual image. So the light rays from an object after reflection does not meet, or it appears to meet when it is produced backwards, then it is called as a virtual image. It will not meet but appears to meet when they are produced backwards. So this is called as a virtual image, and the virtual image will be a erect image. The virtual image will be an erect image, and it cannot be caught on a screen. Virtual image cannot be caught on a screen. So what is a virtual image? So the light rays from an object after reflection, it does not meet but appears to meet when it is produced backwards. So this is called as a virtual image. The virtual image will be an erect image, and the virtual image cannot be caught on a screen. So next, let us learn about the curved mirrors. So there are different types of curved mirrors. They are the parabolic mirrors, the spherical mirrors, etc. But the commonly used curved mirrors are the spherical mirrors. So what is a spherical mirror? In a spherical mirror, the reflecting surface will be a part of a sphere. So what is a spherical mirror? In a spherical mirror, the reflecting surface will be a part of a sphere. So such a type of mirrors are called as spherical mirrors. So what is a spherical mirror? The reflecting surface will be part of a sphere. So such a type of mirror is called as a spherical mirror. There are two types of spherical mirrors. So one is a concave mirror. So in a concave mirror, the reflecting surface is curved inwards. So that is called as a concave mirror. So what is a concave mirror? If the reflecting surface is curved inwards, it is called as a concave mirror. The next one is the convex mirror. So what is a convex mirror? So convex mirror is also a spherical mirror in which the reflecting surface is curved outwards. It is called as a convex mirror. So what is a spherical mirror? If the reflecting surface is a part of a sphere, then it is a spherical mirror. And there are two types of spherical mirror. One is a concave mirror in which the reflecting surface is curved inwards, and next one is a convex mirror in which the reflecting surface is curved outwards. So now let us learn the rules for the construction of image in a spherical mirror. So the first rule is that a ray that is passing through a center of curvature. A light ray that is passing through the center of C is the center of curvature, F is the principal focus and P is the pole of the mirror. So a light ray passing through the center of curvature is always reflected back along its own path. So what is the first rule? A ray passing through the center of curvature after reflection will be reflected along its own path. The second rule is that a ray which is passing parallel to the principal axis. So this is the principal axis. The line that is passing through the pole is called as the principal axis. So a ray passing parallel to the principal axis, after reflection, it appears to be coming through the principal focus. So this is the second rule. So a ray which is parallel to the principal axis, after reflection, appears to be coming through the principal focus. This is the second rule. The third rule is a ray that is passing through the principal focus after reflection. After reflection, it travels parallel to the principal axis. So this is the third rule. A ray which is passing through the principal focus after reflection travels parallel to the principal axis. So this is the third rule. The fourth rule is a ray that is incident at the pole. A ray that is incident at the pole, it is after reflection, it forms an angle. So I and this is R. So that the angle of incidence is equal to angle of reflection. So the fourth rule is that a ray that is getting incident at the pole P, it reflects forming an angle I and R. So the angle of incidence will be equal to angle of reflection. These are the four rules of the construction of the image in a spherical mirror. What is the first rule? The first rule is that the light ray that is passing through the curvature, center of curvature C. So when the light ray is passing through a center of curvature C, it will be reflected along the same path. And the second rule is that the light ray which is parallel to the principal axis will be reflected through the principal focus. So the second one is light rays parallel to principal axis will be reflected through the principal focus. So this is the second rule. And the third rule is that the light ray which is passing through the principal focus, the light ray which is passing through the principal focus will be parallel after reflection. It will be parallel to the principal axis. And the fourth rule is that if a ray gets incident at the pole, it gets reflected and forms an angle, so that the angle of incidence will be equal to the angle of reflection. So these are the four rules. In today's class, we have learnt about the laws of reflection, the first law is that the incident ray, the reflected ray and the normal all lie in the same plane. And the second law is that the incident ray will be, the angle of incidence will be equal to the angle of reflection. And then we have learnt about lateral inversion, So what is lateral inversion? It is the apparent inversion of left and right in a plane mirror especially. And the next we have learnt about real and virtual image. So real image can be caught on a screen and virtual image cannot be caught on a screen. And the next we have learnt about the spherical mirrors. So there are two types of spherical mirrors, concave mirror and convex mirror. And also we have learnt the rules for the construction of image in a spherical mirror. Thank you, students.